Welcome to Chapter 14, Part 4. We're going to cover degrees of unsaturation. So it's kind of a random topic at the end of this section, but it's going to make sense as we get into solving bigger problems where we have a formula and an IR spectrum and an NMR spectrum, and we are trying to put together the identity of a molecule. So let's talk about what this means. Degrees of unsaturation. Now, in Klein and in your sapling homework, sometimes you might see this referred to as HDI. That's going to be your hydrogen deficiency index. That's probably the last time you're going to hear me say HDI. I'm going to go with degrees of unsaturation. When we talk about an alkane, we often say, is it saturated or unsaturated? And if it is an open chain, so no rings, alkane, no double bonds, we would say that it is saturated, right? So fully saturated alkanes follow this pretty simple formula. CnH2n plus 2, right? You have as many bonds to hydrogen as possible. So something like methane, that's pretty easy, CH4. Ethane, you're going to have CH3, right? 2 carbons, 6 hydrogens, and so forth. When you start to bring in a double bond or a ring, there is less hydrogen than this sort of total amount possible for 2 carbons. So we say that this one is unsaturated. Right now, we see that we've gone from 6 hydrogen to 4 hydrogen. So every double bond causes us to lose 2 hydrogen. Let's think about propane, right? This is going to be C3H8, 2n plus 2. Now, if we were to make that into a ring, right, that's going to be C3H6. So again, it's a loss of 2, so this is unsaturated as well. Every double bond or ring is 1 degree of unsaturation, meaning you lost 2 hydrogen, so minus 2 hydrogen, right, from that possible total. Triple bonds, if we were to take a look at just the simplest one, we've gone from C2H6 down to C2H2. We've lost 4 hydrogens. So a triple bond, we say, has 2 degrees of unsaturation, right? Loss of 4 hydrogens from that possible total. So when you have a chemical formula, but you don't know the structure, it can be helpful to think about, okay, how many degrees of unsaturation? That gives you at least some possibilities of what functional groups you could see in your molecule, right? So if I get C5H12, well, I know that's going to be no double bonds, no triple bonds, no rings, because I have 5 is N, and then 5 times 2 plus 2 would be 12. Whereas if I have C5H10, I'm down to, there is 1 degree of unsaturation, could be a double bond or could be a ring somewhere in the molecule. If I'm down 4, right, that's 2 degrees of unsaturation, could be 2 double bonds, 2 rings, a double bond and a ring, or a triple bond. This can be helpful when trying to come up with possible structures. Now, of course, this gets much, much harder as the compound gets larger. The possible isomers goes up exponentially. But for something simple like C4H6, it's got 2 degrees of unsaturation, right? Because if it was fully saturated, it would be C4H10, right? So it's either got 2 double bonds, a triple bond, 2 rings, or a ring and a double bond. So these are all the possibilities. Just to be clear, I am not going to ask you to do this. I'm not going to ask you to give me all possibilities, but it can help you when you're analyzing spectra to know if a double bond's even possible or an aromatic ring is even on the table. And so I always suggest doing degrees of unsaturation first in solving more complex problems. Now, the issue with this is we're not only dealing with hydrocarbons. So what about oxygen, nitrogen, or a halogen? How are those going to affect things? I'm going to quickly go through these slides because I like to just use a formula to solve this, but let's discuss each quickly here. Your halogens do not affect saturation because they take the place of a hydrogen, right? So if I have 5 hydrogens in a chlorine, well, that's like I have 6 hydrogens. It's still fully saturated. It is monovalent, just like hydrogen. So the presence of a halogen will replace a hydrogen. Oxygen does not affect the HDI or degrees of unsaturation at all. You don't even have to think about it. It either fits in between a hydrogen and the carbon or 2 carbons, and it does not affect how many hydrogens could be present. So oxygen, it doesn't affect it at all. Nitrogen's an interesting one because it causes you to need 1 more hydrogen than is expected otherwise. So you have to add 1 when you have a nitrogen. So taking all of that into account, figuring out degrees of unsaturation is pretty easy. You take 2 times the number of carbon that you have plus 2. You're going to add however many nitrogens you have because you need 1 more hydrogen for every nitrogen. And then, because this would give you the saturated amount of hydrogen, you're going to subtract the number of hydrogen you have and any of your halogens, because your halogens work just like hydrogen. Then, because each degree represents 1 hydrogen or 2 hydrogens, you're going to divide it by 2. And that is how you get degrees of unsaturation. So, for instance, let's see if there is a practice problem here. Maybe not. For example, HDI equals 0. That's great because that tells you no rings, no double bonds, no triple bonds. If you have a degree of unsaturation, right, there's a few different options. Okay. When we work through some problems after we get through chapter 15, this will be something that I do frequently. Right, I will solve for degrees of unsaturation first. So this little primer video should help with that. Next, you will hear from me. We will be entering chapter 15. There should be some practice on degrees of unsaturation in your homework.